There is a tool every beekeeper reaches for without thinking. Not the smoker, not the brush, the hive tool. And the first thing most beekeepers do when they open a hive is use it to scrape the propolis along the inner cover, the seams between boxes, the frame rests. Everything the bees have spent days laying down, the beekeeper spends 3 minutes removing. It is a habit so ingrained that most people never stop to question it. Tidy equipment, clean surfaces, frames that lift without a fight. That is what good hive management looks like. Or at least that is what it has been taught to look like for the better part of 150 years. But here is what that habit never asked. What is the colony losing when you scrape it clean? What were those bees building, and why? The answer changes how you think about every inspection you have ever done, and it connects to a biological mechanism that honeybee colonies have been running for 50 million years, inside structures that look nothing like the boxes most of us work with today. If the biology behind how colonies actually defend themselves is the kind of content that sharpens your management, a like on this video goes a long way. And if you have ever wondered whether that propolis was doing something real while you were removing it, leave that below. Before there were hive boxes, before there were frames, before there was any equipment at all, honeybee colonies nested in hollow trees. They still do, when they get the chance. A swarm issued from a managed apiary, if it finds a tree cavity before a beekeeper finds it, will occupy that cavity and begin transforming it within days, not decorating it, transforming it. And what a colony does inside a hollow tree is not what a colony does inside a Langstroth box. Not because the bees are different, because the walls are. A tree cavity is rough. The interior surface of a hollow trunk is irregular, layered with bark ridges, wood grain, old cambium, the biological texture of something that grew for decades before it became a nest site. That roughness is not incidental to the colony. It is the first thing the bees respond to when they move in. When bees occupy a rough-walled cavity, they do something that bees in smooth boxes almost never do at the same scale. They coat the walls, not with wax, with propolis. Propolis is a compound material that bees collect from the resinous buds and bark of plants, conifers, poplars, birches, willows, whatever resin-producing vegetation exists within foraging range. They blend those plant resins with beeswax and salivary enzymes and produce a substance whose antimicrobial properties are not incidental. They are the point. Propolis contains flavonoids, phenolic acids and terpenes, compounds with demonstrated activity against bacteria and fungi. The bees are not applying this material to cavity walls because it happens to be available. They are applying it because the nest environment requires it. In a tree cavity, bees deposit this resin layer by layer over weeks and months, working the material into every crack, every ridge, every irregular surface the cavity provides. Researchers who have studied this now call what the bees construct a propolis envelope, a contiguous antimicrobial lining that covers the nest cavity from the entrance to the uppermost point the colony occupies. In a well-established tree cavity colony, this envelope is not thin. It is a substantial coating, visibly darker than bare wood, built up over years of continuous deposition. This is not housekeeping. It is not gap-filling. It is a constructed immune environment. The colony is not simply living inside a tree. It is living inside a structure it has biologically modified to suppress the pathogens that would otherwise threaten it. That is what bees build when the architecture allows it. That is what they have been building inside rough-walled cavities for longer than the genus Homo has existed. The question that 19th century American beekeeping never asked was what happens to that behavior when you put those same bees inside a smooth wooden box. L.L. Langstroth described the movable frame hive in 1851, and it changed American beekeeping permanently. The ability to remove individual combs, to inspect the brood nest without destruction, to manage the colony's condition across a full season. These were genuine biological and practical advances that made commercial honey production possible at scale. None of that is in question, but the boxes in which those frames hung were manufactured, And manufactured goods are built to tolerances: smooth planed lumber, regular dimensions, tight joints, a hive body that could be built to a standard, assembled quickly, stacked, stored, and shipped. The interior surfaces of a commercial Langstroth box are smooth, not rough like bark, not textured like the inside of a hollow tree. Smooth, planed wood ready for frames and bees. And here is the biological consequence that nobody measured until the 21st century. Bees require a tactile surface stimulus to deposit propolis on walls at the scale that produces an envelope. In a rough-walled cavity, the cracks, ridges, and surface irregularities create the trigger that causes foragers carrying resin to pack it into gaps and coat the surrounding area. The behavior accumulates. The envelope grows. In a smooth box, that stimulus is largely absent. Bees will still propolis the frame rests, the seams between boxes, the gap around the inner cover, the joints, the edges, places where some roughness or small opening exists. But they do not coat the interior walls because the interior walls give them nothing to respond to. The behavior is not suppressed by anything the bees are doing or failing to do. The architecture removed the condition the behavior depends on. The result is a managed colony living in a propolis-poor environment, not through any deliberate decision, not through beekeeper error, because the manufacturing standard that made commercial beekeeping economically viable happened to eliminate the environmental feature that bees use to construct their primary nest-level disease defense. The transition from log hive to smooth Langstroth box was a practical and economic decision. Its biological cost was unintended and went unnoticed for generations. But the pattern was noticed, not in research publications, but in the working observations of beekeepers who managed colonies in the equipment that preceded smooth commercial boxes. Moses Quinby, documented as one of the first commercial beekeepers in the United States, managed as many as 1,200 colonies in New York's Mohawk Valley during the mid-1800s. Before the Langstroth design became universal, the American beekeeping tradition he worked within was built on log hives, hollow sections of tree trunk, capped top and bottom, set upright in the apiary. The interior walls of a log hive are rough, not polished, not planed, the same surface character that a wild colony selects naturally. Colonies maintained in those hives were described repeatedly in early American beekeeping literature as hardy, as carrying disease pressure that would collapse managed box colonies in the same region. Early commercial operators working Appalachian gum hives, hollow sections of black gum or tupelo, noted the same pattern across multiple generations of beekeepers in the same communities. The colonies in rough-walled cavities seemed to need less intervention. They overwintered with fewer losses. They managed brood disease pressure that their neighbours' box hive colonies did not. Those beekeepers attributed this to genetics, to location, to simplicity of management, to the self-selection of colonies that survived in hollow trees without assistance. These explanations were not wrong, but they were incomplete. The rough-walled interior was doing biological work that no one had a framework to credit. Most modern beekeeping advice gets this exactly backwards. The instinct that developed alongside smooth commercial equipment was the opposite of what the log hive tradition had maintained. Scrape the propolis, keep equipment clean, tidy boxes reflect good management. That instinct was not unreasonable given what beekeepers were told. It was consistently reinforced by the published literature and the commercial culture that surrounded it, and it compounded the problem that smooth equipment had already created. What changed the picture was measurement, not observation that colonies in rough boxes seemed stronger, actual measurement of what was biologically different between propolis-rich and propolis-poor environments at the level of pathogen loads and individual bee physiology. Research assessing colonies in smooth planed boxes, boxes fitted with textured surfaces on their interior walls, and rough sawn wood boxes with unfinished interiors documented consistent findings across multiple seasons and multiple apiary contexts, including colonies in migratory operations moved repeatedly across different disease environments. The results were more specific than the historical pattern of observation had suggested, and the most important finding was not the one that most beekeepers would predict. Colonies in propolis-rich environments showed measurably lower pathogen loads. That was expected. Propolis has known antimicrobial properties. The envelope reducing bacterial and fungal pressure in the nest environment is biologically plausible, and the data confirmed it. But the second finding went deeper than that. Individual immune gene expression in worker bees from propolis-rich colonies was decreased compared to bees from smooth box colonies. And that is the number that changes everything about how this should be understood. Most beekeepers would assume that high immune gene expression means a healthy, well-defended colony. The immune system is active. The bees are fighting. That sounds like the right direction. It is not. High immune gene expression means bees that are actively mounting a defense against pathogen pressure in their immediate environment. Immune function is metabolically expensive. A bee sustaining a continuous immune response is spending energy on that response, energy that cannot go into nursing brood, into building wax, into the foraging efficiency and gland function that every other colony process depends on. She is being asked to fight at the cellular level in every waking moment, because the nest she lives in provides no environmental defense against the pathogens she is constantly encountering. Low immune gene expression in propolis-rich colonies does not mean the bees are undefended. It means the architecture of the nest is handling the pathogen load before it reaches the bees. The propolis envelope is doing antimicrobial work at the environmental level. The bees' individual immune systems are quieter because they have substantially less to fight. The colony in the propolis-coated hive is not working harder than the one in the clean box. It is working less hard because the environment the bees built, the resin-coated walls, the compound antimicrobial lining, is managing pathogen pressure at a level upstream of the bees themselves. Their immune systems are held in reserve rather than continuously deployed. The cleaner the box, the harder the bees work to stay alive. That is what the research documented. That is what the log hive beekeepers in Quimby's era observed as outcome across season after season, without the language to explain the mechanism. And that is what the scraping habit, reinforced across 150 years of smooth box beekeeping culture, has been removing one inspection at a time. Propolis isn't the problem. It was never the problem. If this kind of biology-first reasoning is what you come to this channel for, subscribe. There is more ahead. The practical question from here is direct. If smooth planed interiors suppress propolis deposition and rough surfaces restore it, what does a beekeeper actually do? The first answer is the simplest, and the one that costs nothing at all. Stop scraping where scraping is not necessary. Not everywhere, not where propolis is genuinely preventing function. An inner cover glued so tight that the seal creates a moisture problem. Frames that are bridged together and cannot be separated for inspection without comb damage. Those get managed. That is legitimate hive work. But the routine habit of scraping interior walls clean, clearing the corner deposits, removing the thin resin film that workers are slowly building along the wood grain in the upper corners of the brood chamber, that habit is removing what the colony is trying to construct. Leaving it there changes nothing about hive management. It changes the environment those bees are living in. The second answer involves the surfaces themselves. Saw cuffs cut into the interior walls of brood chambers. Shallow parallel cuts made with a handsaw before the equipment is put into service provide the textural stimulus that triggers propolis deposition. The cuts do not need to be deep. 1/8 of an inch is sufficient. The texture is the signal. Beekeepers who have done this with otherwise standard equipment report measurably heavier propolis deposition on interior surfaces within a single season. The bees don't require a tree cavity. They require something to respond to, and they respond quickly when they find it. Leaving interior wood surfaces unfinished serves the same purpose. The tendency toward painted, sealed, smooth interior surfaces in commercially manufactured equipment is driven by legitimate concerns: durability, moisture management, pest pressure from wax moths and small hive beetles. The exterior of a hive body should be protected. The interior does not benefit from the same treatment, and may actively work against the behavior the colony needs to complete its nest-level immune defense. None of this requires new equipment. None of it requires a purchase, a treatment schedule, or a management protocol that adds complexity to the apiary season. It requires understanding what the bees are building and getting out of the way. Consider the beekeeper who has kept careful equipment for 3 decades. Smooth interiors, frame rests scraped clean at every inspection, boxes that opened without a fight and stacked without gaps. He took that standard as a mark of sound practice. In many ways it was. His timing, his reading of brood nest condition, his disease assessment, none of that was undermined by the scraping habit. He was a good beekeeper, but every time he ran that hive tool along the interior wall, he removed something his bees had spent real energy producing. Not waste, not obstruction, a biological output the colony had been building, layer by patient layer, as part of a defense system that was already ancient when the first Langstroth box was assembled. He didn't know that. Nobody told him. The advice he received, the publications he read, the extension literature, and the club consensus, all of it reinforced the clean equipment standard. The biology wasn't part of the conversation because the biology hadn't been measured yet. It has been now, and the measurement confirms what the log hive beekeepers observed across generations and couldn't explain. A colony that builds its propolis envelope freely is a biologically different colony from one that does not. Not different in genetics, not different in queen quality or forage access or seasonal timing. Different in the environment it has been allowed to construct for itself inside the 4 walls of the box it lives in. The bees in a hollow tree do not live in a pristine space. The walls are rough, dark with accumulated resin built up over years of continuous colony effort. From the outside it looks like neglect. From the inside it is a constructed antimicrobial environment that allows every bee in that colony to spend less of her physiology on defense and more of it on the functions the colony needs to thrive. That environment is available to any managed colony given the conditions to produce it. Rough surfaces, restraint with the hive tool, time. The bees build what they need. The question has always been whether the box allows it. Next time you open a hive and reach for that hive tool, there is a different question worth asking before you scrape. Not whether the propolis is in your way, but what the colony is trying to build, and whether what you are about to do makes that easier or harder. If this has changed how you think about propolis, whether you have been scraping for 5 years or 50, leave that below and subscribe. There is more forgotten precision ahead, the kind the bees have been practicing long before the books caught up.